Hi, welcome back. Today we are going to see about the single phase energy meter. So, according to the physics, the energy is the ability of work done with respect to time is called energy. So, it can be measured by using the energy meter. So, now you can see the case. What he is doing, he is taking the reading of energy meter. How do he calculate? So, here how he calculating the amount of energy can be used, why he should measure the energy meter, and if we are having any experiences, share in the comment box. So this is the single phase energy meter, which is used to measure the energy, or the amount of power which is utilized during the particular amount of time, the particular interval of time. So this can be used in the domestic and as well as commercial purposes where we are using the single phase power supply. And this is the construction of energy meter. So here the energy meter, it has two electromagnet. One is called lower electromagnet, and another one is called upper electromagnet. This is called upper electromagnet. Okay, so this is called phase and this is called neutral. Now the current which is coming from the phase, which is connected with the load, the another end of the load which is directly connected with the neutral through the lower electromagnet. So now we can, from this figure, the lower electromagnet which is connected in series with the load, Similarly, okay, the upper electromagnet, now we can see, we can take it from the phase, and from the phase which is connected with the upper electromagnet, from this again it is connected with the neutral. So the upper electromagnet which is connected across the source or across the load, or it may be across the load. So normally an energy meter, it consists of two coil. One is upper electromagnet, another one is lower electromagnet. The lower electromagnet which is connected in series with the load, and the lower electromagnet which is connected in series with the load, and upper electromagnet which is connected in parallel with load. So here the lower electromagnet is called current coil. And the upper electromagnet is called pressure coil, voltage coil, okay, or it may be potential coil. We can call it as potential coil also. So in between the two voltage coil and pressure coil, so there will be an aluminum disc. So in this aluminum disc we are connecting the spindle. Okay, so and the spindle, it will be the end of the spindle which is connected with the recording mechanism. Readings will be there. So with the help of small gearboxes. Okay, and here there will be a braking magnet, so which is used to hold the rotation of aluminum disc when the load is disconnected, when there is no load is inactive. Okay, so that initially if the load is increases, the amount of current drawn by the load is increases. So if the current is drawn, the current which is flowing through the current coil is also gets increases. So the current coil, it produces the fluxes. The current coil is getting energization and it produces flux. The produced flux depends on the load, and the pressure coil is getting magnetization. Okay, so here the pressure coil is connected in parallel with the source and load. So here the current which is entering into the pressure coil is always same. So the pressure coil, it always produces the constant flux. It produces the constant fluxes, but the current coil, it produces the flux which depends on the load. If the load current is increases, the flux produced by the current coil is also gets increases. Okay, so the interaction of these two fluxes, the flux which is produced by the pressure coil and the flux which is produced by the current coil, so both the fluxes will be interacted on the aluminum disc, so that there will be a tendency across the aluminum disc, so the aluminum disc gets rotating. So if the aluminum disc is rotating, the spindle which is connected is also gets rotating. If the spindle is rotating, so automatically we can able to count down the readings. Okay, because by using the small amount of gearboxes, the reading gets rotated. If there is no load, if all the loads are disconnected, in order to avoid the rotation of aluminum disc, there will be a magnetic braking magnet, the braking magnet which is used to hold the aluminum disc not to rotate when the load is not there. Okay, so this is the construction of a single phase energy meter. So this is the 3D view of energy meter, and this is the assessment. The household energy meter is an indicating instrument or recording instrument or an integrating instrument or none of the above. The meter constant of single phase energy meter is expressed in terms of revolution per kilowatt hour, kilowatt divided by kilowatt hour, amps per kilowatt, volt per kilowatt hour. So put your answer in the comment section. So these are the mechanism in the energy meter. There are 4 mechanism. One is driving system, another one is moving system, another one is braking system, and fourth one is registering system. So the driving system, which is used to drive the aluminum disc, it is with respect to the load. And the moving system, so if the load is increases, the aluminum disc gets rotated based on the interaction of the 2 fluxes which is produced by the upper magnet and a lower electromagnet. And the braking system, if there is no load is connected, so the braking system which is used to hold the aluminum disc for not to rotate. And this is the registering system, that is called counting mechanism. So according to the load increases, the spindle rotate, so that based on that it record how many revolution is completed. So that can be done by the registration or counting mechanism. And this is the assessment. If voltage supply to the energy meter is more than the rated value, energy meter will run slow, fast, either of the above, none of the above. And second one, aluminum is selected as the best, is selected as the material for rotating disc of energy meter. It is because it is a good conductor, and or it is a lightweight, or it is an indigenously available, or all the above reasons. So put your answer in the comment section, and these are the few references. Thank you.